I want to run through a few examples of sets that do or do not have a one-to-one correspondence with each other. These sets are a little messy, a little real world, so we have to think a little creatively sometimes about whether there's a correspondence or not. So I would claim that the set of dog noses and the set of dogs have a one-to-one correspondence, and there might be some tragic dogs that do not have any noses, but I think for the most part, you can say that every dog has a nose, that dogs generally do not have two noses, that they generally do not have no noses, and very importantly, there are no dog noses out there without dogs. So these two sets, I say, have a one-to-one correspondence. Number of fingers and number of toes on a human being. And, of course, there are people who have had injuries or are born without some of their digits, but for the most part, there's a one-to-one correspondence between fingers and toes. You can hold up your fingers to your toes and physically execute that one-to-one correspondence. And finally, I would say that for the most part, there is a one-to-one correspondence between cars that are on the road and drivers of cars. Now, there are self-driving vehicles out there, but as far as I know, there's still a human driver in the car, just their hands aren't on the wheel. So, although this may change in the future, I say there's a one-to-one correspondence between car drivers and cars that are on the road. For a few examples that don't have a one-to-one correspondence, I would say that for most classes, there is not a one-to-one correspondence between students in a class and teachers in a class. Typically, there would be many more students than teachers, and so you can't make a perfect matching between those two sets. Number of days in a year versus number of months in a year. And here, let's just use what we know about numbers and count. I mean, there's either 365 or 366 days in a year, and there's only ever 12 months in a year. So although all of the days are matched with months, I mean, February has 28 days or 29 days matched to it, right? So that is not a one-to-one correspondence, even though there's a type of correspondence there. Days in 2016 versus days in 2017. If you remember, 2016 was a leap year, and so it had more days than 2017, and you can't establish a one-to-one correspondence. So for a math example, let's think about the set of all natural numbers, so 1, 2, 3, 4, and so on and so forth, and the set of all natural numbers that are less than 10, that's 1 through 9. So you could write those numbers 1 through 9 and try to do a matching, and there are going to be lots of leftover numbers with no buddies, and so this is not a one-to-one correspondence. But really importantly, you could try to spread out those 9 numbers, or you could shuffle them around. It doesn't really matter what you do. The proof here is that the natural numbers less than 10, there are only 9 of them, right? And so you can pair those 9 numbers with 9 different natural numbers, any natural numbers that you want. But there are way more natural numbers. There is never going to be a situation in which every single natural number has a buddy on the other side. So there cannot be any one-to-one correspondence possible here. Let's say we have a college and every student at this college is assigned to a dorm room. Does this imply that there's a one-to-one correspondence between dorm rooms and students? So in analyzing this problem and in writing down your response, there are a few things that you could write down to support your argument. So first of all, you might say something like, under certain conditions, yes, there would be. I would accept something like that from you. So what conditions would we need? If every dorm room were full, and if every student had their own dorm room, then yes, therefore we need more information, or therefore this might not be the case. So it's a very intelligent thing to do to say, well, this could be possible under these conditions, and then it's not possible under these other conditions. Or you might just straight up say, look, it's possible that some rooms would be empty, some rooms have no students, or some students have roommates, so some rooms would have multiple students. So it's not likely that this is going to happen. Is there a one-to-one correspondence between U.S. residents and their social security numbers? So mathematically, there are a few things that we need to know that we could start Googling to find out. First of all, are there any residents who do not have a social security number? So you think about the set of all residents on one side and the set of social security numbers on the other. So what I'm asking is, are there any residents on the left side who don't have any number on the other side, any leftover residents? Are there any U.S. residents who have more than one? You want a one-to-one correspondence. You don't want a resident who has multiple social security numbers. Are there multiple U.S. residents who share a social security number? That would also be a really bad thing. And so again, you think about the set of U.S. residents on the left, the set of social security numbers on the right, and we ask, are there any U.S. residents who do not have social security numbers? So there would be a person over here with no matching on the other side. And so I happen to know that the answer to this question is yes, absolutely. At the University of Texas even, we have hundreds of students who come from all over the world to study. And in general, when they come here, they do not apply for social security numbers. They don't need them. And so we have a lot of people who are living here for various reasons who don't have social security numbers. Are there any U.S. residents who have more than one? So you're talking about a person over here in the left set that is matched with multiple social security numbers on the other side. And the reality is that legally you are only supposed to have one, right? But this is up to you. Do you want to consider criminals, right? If you want to think about the case of identity theft or whatever, or people who make up fake social security numbers, maybe you want to consider that in your solution, in which case you would say, yes, and those criminal people are the people who have more than one. Finally, are there U.S. residents who share a social security number? So you're talking about multiple people on the left set who all map to the same social security number on the right side. And again, not legally. Our system is designed that social security number should be your personal identification number, and it's only supposed to go to you. Even if we're talking about illegal activity, in my opinion, if you're using someone else's, then that's a number that actually belongs to someone else. So I'm going to go ahead and say, no, that's not really a concern here. However, if I were writing this problem up, I would be relying on this argument the most personally, that I happen to know many people who live here legally and do not have social security numbers, and so that means there is no one-to-one correspondence.